Okay, factorising this expression, 3x cubed take 14x squared take 7x plus 10, a cubic expression. And we're given one factor, 3x take 2, which allows us just to inspect coefficients of our original expression. So first of all, with our a and c values, the only way we can generate the x cubed term when we expand this expression is by going 3x times by ax squared. In other words, this a value has to be 1 because 3x times x squared would give 3x cubed. So just by inspection, we can say a is equal to 1. Similarly here with the c value, the only way we can generate the constant term of positive 10 is by multiplying negative 2 times c. So that we know that negative 2 times by c is equal to positive 10, which implies that c is equal to negative 5. So negative 2 times negative 5 is positive 10. So now that we've got the a and the c value, we can substitute those values back into our expression. We have 3x take 2 x squared, or rather as x squared is really 1x squared, plus bx, and take 5. Now we just need to find this coefficient b. Now to do that, we can either inspect the x squared term, negative 14x squared, or the x term, negative 7x, and compare coefficients when we expand out our brackets. So I might just start with the first one with the negative 14x squared here. So looking at that, when we expand out this expression, the only way we get x squared terms is when we multiply, first of all, 3x times by bx. That will generate an x squared term. And also the negative 2 times x squared will generate an x squared term. So just expanding those two terms that give the x squared terms, we'll get 3x times bx, or if you like, 3b x squared. And then also we have our negative 2 times x squared, which is negative 2x squared. Now because they're the only terms that give x squared, we can then compare the coefficient of the x squared with our negative 14 of our x squared term in the actual expression. So we can say that that is equal to negative 14 x squared. Now to compare the coefficients, we need to isolate the x squared here. So factorising out the x squared, we get 3b take 2 times x squared is equal to negative 14x squared. So we can then see that 3b take 2 must be equal to negative 14. 3b take 2 is equal to negative 14. Solving that equation, we can add 2 to both sides to get 3b is equal to negative 12, and then dividing both sides by 3. Oops, just move down a bit there. Dividing both sides by 3, we get b is equal to negative 4. Therefore, the final factorised form is 3x take 2 x squared, and our b value was negative 4, c value was negative 5. Once we're down to there, we can do our final factorisation. We've got a quadratic trinomial here. We'll end up with 3x take 2, and we'll have two factors with x in them, and we need two numbers that multiply together to give negative 5, add together to give negative 4. So that'll be negative 5 and positive 1. So there's our final factorised form. Now notice also that we could have got to this b value here by inspecting the negative 7x term instead of the negative 14x squared term. So perhaps we'll have a look at that as well. So what we have instead at this point, looking at the x terms now, the only way when we expand out these two brackets to generate an x term would be by saying 3x times negative 5, which is negative 15x. And also we have negative 2 times bx, which is negative 2bx. And that must be equal to the x term from our original expression, the negative 7x. So from there we can see, well, that should have been a negative 15x, excuse me, make that negative 15x, so the 3x times the negative 5 is negative 15x. We can then factorise out the x. We end up here with negative 15 take 2b multiplied by x is equal to negative 7x, and by inspecting coefficients, the negative 15 take 2b must be equal to negative 7. So there we go. So a little bit of algebra on that one. Let's add 2b to both sides. And at the same time here, I'll add 7 to both sides. So we end up there with 2b equals, what's that, negative 8. And then finally dividing both sides by 2, we get b is equal to negative 4. So our same answer as what we had before. So you can see either way, by comparing either the x squared term or the x term, we can compare coefficients to find the coefficient in front of the x term here.